Hello Grade 9s, welcome to your last lesson for this term. So this is lesson 5. In our last lesson we had a look at how to calculate volume and density of an irregular shape. You already know how to calculate volume of an irregular shape from the work that we did in January, February. And you also learned how to determine the mass of an object using a triple beam balance and an electronic mass balance. And so if you combine the two together, then that'll give you mass and volume. And if you know the mass and the volume of an object, you can then calculate its density. Okay, and then there's the two methods that you can use, either a measuring cylinder or a Eureka can. So being able to do these activities will help you for your test, your practical assignment, which will be due on Monday. Your practical assignment that's due on Monday evening, Monday the 6th of April, we're going to upload that to Teams on Friday morning at 8 o'clock. So you'll have from Friday until Monday to do it. Please don't leave it until Monday afternoon and then try and upload it, because if you've got problems with the internet, then we can't help you. Whereas if you have left it far enough in advance and you maybe do it on Friday, then you've got Friday afternoon to upload it. And if there's a problem with your internet, you can still do it on Saturday. So it gives us a bit of time to help you. Okay, so please try to do it on Friday so that it's done, and then you can enjoy your weekend. With regard to science, I'm not sure what other subjects you've got assignments for that are due next week, but at least your science will be out the way. Alright, I have put the memo for this on Teams, and we ended over here in the last lesson. I did ask you to have a look through sink or float in your last lesson. I hope you did that, but let's read together. So, the density of an object and the density of the liquid that the object's placed in determine whether the object will sink or whether it will float. Even though one object might be heavier than another, the heavy one might float and the lighter one might sink. So if you've got two objects that are exactly the same, maybe let's say a very light plastic disc like a plastic button, and an object that's about the same size of it, so let's say a metal coin. So you've got a 10-cent coin and you've got a button from your shirt. Both are about the same size, but if you put them in water, one might sink and one might float. So another example is a piece of clay and a heavier wax candle placed in water. Even though the wax is heavier than the clay, the wax floats and the clay sinks. Why is that possible? It's possible because it's not the mass of the object that matters in sinking and floating, but it's, if you guessed density, then you are right. But it's density compared to the water or the liquid that it's placed in. So we say that an object that's less dense than water, if it's less dense than water, it will float. And an object that's more dense, in tests and exams, guys, please try to say more dense. More dense. An object that's more dense than water will sink. Okay. So the pink object that you see on the top in the glass of water is floating because it's less dense than the medium, if the medium is water. We call the medium can be the substance that you're using, so water. And the yellow object will sink because it is more dense. So float if it's less dense, sink if it's more dense. And if it's about the same density as water, then it will be neither floating nor sinking, and it will be in the middle if it's got the same density as water. Okay. So this is why the clay sinks in water and the wax floats. The clay is more dense than water and the wax is less dense than water. So we can label this then clay and wax. Okay, so let's have a look at liquids that can float and sink in other liquids. So what we spoke about here, the clay and the wax, those are both solids, but you can also have two different liquids. So sinking and floating applies to liquids too. You can test this carefully by placing different liquids together in a graduated cylinder. So a measuring cylinder or a bottle or any glass container, for example. So if you added vegetable oil is like cooking oil, the oil floats on the water. If you add alcohol, isopropyl alcohol is just a type of alcohol, the alcohol floats on the oil. So what we're saying is that you could have water, I'm going to do the water in blue, you could have a a glass beaker or a measuring cylinder or even a drinking glass that you drink juice or water out of, if you had that and you added water to it, and then you added oil, and then you added alcohol, I'll do the alcohol in green. The alcohol would be the least dense because it floats on top of the oil and the water. The water would be the most dense because it sinks below the alcohol and below the water. So this means that oil is less dense. Than water. So now we're just comparing oil and water. We're not looking at the alcohol yet, just looking at oil and water. We say that the oil is less dense than water and alcohol is less dense than oil. So if we look at the alcohol and the oil, which is more dense, which is less dense, the alcohol we say is less dense. The alcohol is less dense than the oil, and that's why the alcohol floats on top of the oil, because the alcohol is less dense, the oil is more dense. This means that water is more dense than oil, and oil is more dense than alcohol. So you just compare two things, and which one floats is the one that's less dense, the one that sinks is the one that's more dense. So let's look here again. This means that water is more dense. So here we've got water is more dense than oil. So comparing oil and water, water is more dense because it sinks, it's on the bottom. Oil's less dense, floats, it's on the top. And the oil is more dense than the alcohol. So let's change this and look at the oil and the alcohol. So oil and alcohol. Oil and alcohol. Oil is more dense because the oil is on the bottom and the alcohol is on the top. The alcohol floats on the oil, or the oil sinks below the alcohol. So I think by now you've got quite a good idea of how density works. Alright, so the density of an object or the water it's placed in can be changed so that the object that normally sinks will float. So let's have a look at ways to do that. If an object sinks in water, just going to show you where I'm reading. If an object sinks in water, it means that the object is more dense than water. You know that already from when we spoke about the clay. The clay was more dense than the water, so it sinks when placed in water. There are two possible ways to make the object float. So if you wanted to make the clay float, you could either increase the density of the liquid that the solid is in. So you increase the density of the liquid solution so that the solution becomes denser than the object. So say, for example, if I put the clay into a pot of molten metal, then the metal would be more dense than the clay, and you'd actually have clay floating on top of a pot of molten metal. That's not a very practical way of doing things though, but it's just an example that I gave you. If you added salt to water, then the salt water would be more dense than fresh water. And that's actually very true. The ocean has got a lot of salt dissolved in it, you know that. That water has got a higher density than fresh water that doesn't have any salt dissolved in it. So when you guys looked at the crazy Russian hacker with the eggs in the glasses experiment in your scientific method, he put 3 different eggs into each of 3 different glasses. The first glass was fresh water with no salt, the middle glass had some salt added, and the last glass had a lot of salt added. The glass that had a lot of salt added, because the density was greater, that made the egg float on the salty water. So that's what I mean by you can change the density of the liquid solution. Change the density of the liquid solution so that it becomes more dense than the object. So that was what that crazy Russian hacker did. He had a look at the density of an egg in water and salty water, and he changed the density of the water to make it become greater, and that made the egg then float on the water. Refer to your scientific method notes if you're not sure. Okay, so how can you make a solution more dense? Well, I've just told you, you add a solute. And a solute, for example, could be salt. And that increases the mass of the solution, but it only changes the volume slightly. What I mean by that is if you had a glass of water, okay, and it had, let's say, 100 milliliters. That was 100 milliliters of water. Okay, if you then added some salt to it, that salt would then dissolve so that the salt is dissolved in the water. The volume would increase ever so slightly. It might then be, let's say, 101. So it was 100 and it became 101 milliliters for argument's sake. So you add a teaspoon of salt and the volume only increases very, very, very slightly, but the density increases a lot. So you add a solute, for example salt, and what that does, you're going to have to write quite small for this. This increases the mass of the solution. By that I mean the solution would have more mass. So if you had a glass of water and you put it on a mass balance, so that same glass that I had, that had 100 mils in it, if it was resting on a mass balance, it would weigh 100 mils and it would then weigh 100 grams. If I added 10 grams of salt, so a teaspoon of salt, there we go, there's a teaspoon of salt, it goes into there. That would then make the mass balance register 110 grams, so the mass of the water plus the mass of the salt, but the volume would only increase slightly and it would become 101 milliliters, for example. So you increase the mass of the solution, but only change the volume slightly. So if you increase the mass of the solution and you only change the volume slightly, remember the formula for density. Density is mass per unit volume. Okay, so if I increase the mass and the volume is almost the same, so let's ignore that the volume changed. You're dividing a bigger number by a smaller number, which means that the density is going to increase as well. So let's say that your mass was 100 and your volume was 100. Your density then would be equal to 1. Whereas if you added some salt to your 100 mils of liquid, then your mass would be, if you added 10 grams of salt, then your mass would be 110 grams. And your volume, I said, increased ever so slightly. So let's go by 100. That would give you a value of 1,1. And obviously 1 and 1,1 are not the same, which means that you've increased the density by increasing the mass. Okay. Another way that you can change the change whether an object floats or sinks in a liquid is to increase the volume of the object so that the object becomes less dense than water. How could you do that? Let's say, for example, that you had a balloon and you put a few pieces of rice inside your balloon. Let's say you have a balloon and you put a few bits of metal. So let's say you put some coins, some 10-cent coins into your balloon. You don't put air in it, and you then put that into a glass of water. So there's our glass of water, and there's the balloon. I'm not going to make it a balloon shape because it's got some coins in it. There's 3 coins inside the balloon. I'm sure you'd agree that the balloon would sink to the bottom of the water. Okay. If you took the balloon out and you kept the coins in it, but then you blew it up. So let's have a blown up balloon, and it's now got the 3 coins still in it. You should agree that that balloon is actually not going to sink anymore. It's going to be floating on the surface of the water. And the reason why is because by increasing the volume, you've decreased the density. So you can expand or inflate the object. You can do that by expand or inflate. Inflate means to fill up with air, the object. Okay. So remember, when you've got the balloon with without any air in it, it would be very small. It would have a very small volume. And if you had the metal coins in the balloon would sink to the bottom of a glass of water. But if you blow up the balloon, you increase the volume, And if you increase the volume, you decrease the density. And that's why then the balloon has still got the coins in it, but it would float on water. And that's also that is why the principle behind which ships float on water. So back to this equation. If the mass of the empty balloon was, let's say, 50 grams. Okay, so the mass of the empty balloon, let's go with empty. The mass is 50 grams and the volume is 100 milliliters. 50 divided by 100 would give us a density of a half, 0.5. However, when you blow up the balloon with air, so when it's filled with air, it would still weigh 50 grams because the air won't really make the mass increase very much at all. So the mass would stay the same. However, if you increase the volume, it's no longer going to be 100 milliliters, for example. If the balloon was 100 when it just had the coins in with no air, let's make it be 10 times as big, 1,000. That then means that the density would be 0.05. And obviously 0.5 is much different to 0.05. So by filling up the balloon with air, you've decreased its density. And that's why it would then float on water. Okay, then the last part of this lesson is to explain why heavy ships float. There are 2 videos here, and I've also actually found a third one for you. I'm going to put those links onto Teams for you, and I'd like you to watch the 3 videos. So this video, and the third one that I found that's quite nice. It explains why ships float, kind of like the balloon and the coin in water example, but with a little bit more detail. Then I'd like you to come up with your own explanation, either do it in pencil or on another piece of paper. And once you've done that, then I will compare it with you. So you can see whether your explanation matches and if you understand what's happening. So that's all the teaching that's going to happen for this term. Next term, we are going to carry on with the temperature of a substance and how temperature affects a substance's density. You'll actually see that a hotter substance expands, and that affects its density. So grade 8, thank you. Please remember to check on Teams for Friday for your assignment. Make sure you've got everything that I told you would need. So either a kitchen scale, bathroom scale, kitchen scale is best. If you don't, then send me a message and I'll tell you what to do. You'll also need a measuring jug, so a jug with some measurements on it. Again, if you don't have that, I will tell you how to convert a water bottle and calibrate your water bottle so that you can have a water bottle that's actually a measuring jug as well. Thank you very much. Bye.